And welcome to the final class on Chapter 7, and this lesson is about the perpendicular distance from a point to a line. Now, if we just consider a random line that's drawn on the Cartesian plane, and we'll call the line ax plus by plus c equals 0, so it's in general form, we consider that line and we just consider another point randomly placed anywhere, obviously not on the line. The distance from the point to the line is always considered to be the shortest distance, which is the perpendicular distance. And the perpendicular distance will always be at right angles to the line. If we actually take that shortest distance from the point, and we'll call the point x1, y1 to the line, we use the following formula. D equals the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So that's called the perpendicular distance from a point to a line formula. And it's quite a useful formula to use in this next exercise, obviously. Let's have a look at our first example. Now, for our first example, we've got to find the perpendicular distance from the point 4, minus 3 to the line 5x take 12y plus 2 equals 0. Well, when we look at our line, we're going to end up with a equals 5, b equals minus 12, and c equals 2. Because a is the number in front of x, b is the number in front of y, and c is the constant term. The point that I know gives me an x1 value of 4 and a y1 value of minus 3. So I've now got all the information I need to use my formula. And what was the formula again? The formula is the perpendicular distance equals the absolute value of a x1 plus b y1 plus c all over the square root of a squared plus b squared. So let's see what we get. We get the absolute value of, now a is 5, so it's 5 times x1 is 4, plus b times y1 will be negative 12 times negative 3, plus c, which is 2, all over the square root of a squared, 5 squared, plus b squared, which is negative 12 squared. Now, when you put the numerator into a calculator or process it, you'll end up with 20 plus 36 plus 2, which will give you 58, but it's inside an absolute value sign, over the square root of 5 squared plus 12 squared will give you 13. So that equals 58 over 13. Or, if you prefer, instead of using 58 over 13, you could say that's 4 and 6/13 units, and that's how far it is from the point to the line via the shortest distance or the perpendicular distance. Let's try and go on to example number 2. For example number 2, we have to prove that the line 3x take 4y plus 15 equals 0 is a tangent to the circle x squared plus y squared equals 9. Now what does x squared plus y squared equals 9 look like? Well, for a circle, x squared plus y squared equals 9 would have a radius of 3 because the square root of 9 is 3. And we have to prove that the line is a tangent to the circle. Well, to prove the line is a tangent to circle, what we actually need to have then, I mean, I don't know where the line is going. Let's randomly draw it going through like that. If it was a tangent to the circle, it would touch the circle just once and it would create a right angle going back to the centre of the circle, which means if I take the centre of the circle as my point, and I find the distance from that point, the centre of the circle, to my line. If that distance is 3, which is the radius of the circle, then that line is a tangent. If the distance is not 3, then it's not the radius of the circle, it's not a tangent. So let's actually try doing that and see what we can generate. Let's have a look at our line. The line is 3x take 4y plus 15, so we have an A value of 3, a B value of minus 4, and a C value of 15, and x1 is equal to 0 and y1 equals 0 because I'm using the point 0, 0 as my point. Let's write down the formula. D equals absolute value of ax1 plus by1 plus c over square root of a squared plus b squared. Let's plug the values in. I'm actually going to multiply them. A is 3, x1 is 0, and 3 times 0 is 0, plus b is minus 4, y1 is 0, minus 4 times 0 is 0, plus c, all over the square root of a squared, 3 squared is 9, plus b squared minus 4 times minus 4 is 16, which leaves me with the absolute value of 15 over square root of 25 is 5. The absolute value of 15 is 15, and 15 over 5 is 3. So, the distance from the point 0, 0 to the line is 3 units. That's also the radius of the circle, which means, yes, the line is a tangent to our circle because it's 3 units, which is also the radius of the circle. Okay, let's go to example number 3, our final example. We need to show that those 2 points lay on the same side of the line 2x take 3y. Okay, let's try plus 4 equals 0. Let's try figuring out what A, B and C are. A is 2, B is minus 3, and C is 4. So let's look at the point minus 1, 3 first. Let's find the distance from that point to the line, but I'm going to do something a little bit different. Notice I didn't put the absolute value signs on. And I haven't done that intentionally. So let's call this distance 1. And we'll talk about why I didn't put the absolute value signs on in a moment. Let's plug the numbers in. A times the x value of my first point. That's 2 times minus 1. Plus B times the y value of my first point. That's negative 3 times 3. Plus C, all over the square root of, now what's my A number? 2. 2 squared is 4. What's by B? Minus 3. Minus 3 squared is 9, which gives me an answer of minus 2 minus 3 is minus 5. Minus 5 plus 4 is minus 1 over the square root of 13. Let's just stop there and go on to finding our distance from the point 2, 7. I'll call this distance 2. Here's our formula. Notice I'm not putting the absolute value signs on. Let's plug in the values. A times x1, 2 times 2, plus B times y1, minus 3 times 7, plus the C over square root of a squared. Well, it's going to be exactly the same as before. 4 plus 9, which equals, now 4 take away 21 is minus 17, plus 4 is minus 13 over the square root of 13. Now the trick is to actually figure out why I bothered not putting the absolute value signs on. Now because I didn't put the absolute value signs on, you'll notice that for distance 1 I got a negative answer, and distance 2 I got a negative answer. If those signs are the same, that means they're both negative, or they're both positive, that means those points are on the same side of the line. All negative answers are on one side of our line, and all positive answers are on the other side of the line. So we can say yes, the points are on the same side of our line. And now it's time for you to try some questions. Have fun.